All right. Hello, everyone. My name is Petr Horáček, and I've been working. Hello?
Please speak a bit louder.
Yeah, there is no speakers.
There's no mic here.
Okay, if I lose my voice between we finish, sorry about it. So, hello again. My name is Petr Horáček, and I've been working in Red Hat for over 4 years now. I spent 3 years on a project called Overt, aka Red Hat Virtualization, and a year ago I joined a new project called Kubernetes. Now, both of these projects deal with one task, one difficult task, maybe two of them. The first one is virtualization, but another one, not so obvious, is managing quite complex scenarios for networking, being configuration of host networking for storage or management, and connecting of VMs altogether. And there are other virtualization project that will with the same problems. The problem is that all of them, or most of them, develop their own solutions to manage networking, and that's where NMState or Kubernetes NMState came. So Kubernetes NMState is a tool that can be used by all these projects, or NMState at least, and it allows you to it provides you a simple tool to configure your networking in a declarative way. So, in this talk, I will tell you about NMState, Kubernetes NMState, and I will try to do a live demo. So, in Kubernetes, usually what is enough for you is the default networking, which connects all your pods or VMs with a Kubert together to one interruptible network. However, sometimes you need something more complex, like connecting your pods to multiple L2 networks using SRIOV and so on. And the need for this kind of configuration is not necessarily on day one. Sometimes you decide that you need multiple networks on the second week of your Kubernetes cluster running, and then what do you use? Ansible, or you SSH to the host and configure it manually? You can do it, but it's tedious. So you can use NMState to just describe the desired state of the network, and it applies it for you. Compared to a network manager, which works in an imperative way when you say, I want to add this profile to configure this, or remove the profile and remove interfaces, for instance. And network managers is basically a thin layer on top of network manager in this case. And then we have Kubernetes NMState. It is a tool for host networking driven by Kubernetes and configured by NMState, meaning you use your kubectl to control your Kubernetes at pods, manage nodes, and with this add-on you can also configure networking just using kubectl without accessing those nodes explicitly. And Kubernetes NMState introduces two new objects to Kubernetes. The first one is called node network state, which reflects state of networking on a single node. And you can also use it to configure networking on that node. However, it would require you to do this configuration per each node, and to make it easier, you can use another object called node network configuration policy. And it gives you an option to describe, to say that if this interface or if this connection is available on the node, please configure it in this way. And I will get to it later. So let's imagine we have this one single node, and it has two interfaces controlled by network manager. The ETH0 is used for management as a default network, and it has IP address already configured. The ETH1 doesn't, however. So we deploy our add-on for Kubernetes NMState, and it's just a simple daemon set that has NMState in it, which communicates with network manager, and it has a daemon Kubernetes NMState that creates an object per each node called node network state, and it updates it and monitors it for changes. So once this is created, it reflects the network state of the node saying, and this is not the API we use, it's just a simplified version. It says that ETH0 has IP address 10.0.0.1, and there is no IP address on ETH1. So a user can come and see the current state. They also can configure a spec for this node, saying, I want ETH1 to have this IP address. This change is picked up by Kubernetes enum state and applied on ETH1. And this change is then, again, noticed by Kubernetes enum state, and the node network state is updated to reflect this new IP address. So this may be all right if you have just a single node. However, if you have multiple of them, you can use the same mechanism to configure IP address on every single node, but we also added an additional layer with node network configuration policy. In this case, it has this obscure name ETH1-DHCP. And the pink object in the middle is just a controller that monitors this object and updates the node network state accordingly. For instance, if I can have this specification that says, if you find an interface called ETH1 and it's an Ethernet interface, then configure a DHCP, use DHCP to configure IP address on it. So what the control in the middle does, it iterates all node network states, and if it finds this ETH1 interface, it updates this node network state with a new specification to get the desired state. Now, then starts the mechanism already described. Daemon set picks it up and runs uses network manager to run DH client on the interface. It obtains the interface, the state is updated, and so on and so on. This is just a really simple and stupid case, but you might use it for more interesting scenarios, like let's say you have SRIOV cards available on some of your nodes. You can use node network configuration policy to say, if you find an SRIOV card, activate it and configure it so it exposes 8 physical virtual functions. Or if you have LLDP running in your cluster, you can say, if you find an interface that exposes this network using LLDP, then configure a bridge on top of it. Or maybe you have multiple interfaces connected to the same network, so you can just say, if there are multiple of them, you bind them together using a bonding interface and give me this connectivity. All right, now for the demo. In this demo, I will show you how can I check the current state of node networking, and how do I configure the networking, and I will create a virtual machine using KubeVirt and connect it to a default Kubernetes network, but also to an additional one. And just briefly, KubeVirt is an add-on for Kubernetes that allows you to run virtual machines side by side with your pods, so you use the same infrastructure to handle both VMs and containers. And then Multus is a networking plugin in Kubernetes that allows you to connect your pod to multiple networks. And finally, OVS CNI is a plugin, again, networking plugin, that connects your pod to an OVS bridge. Okay, so this will be, I hope we will end up in this state with the demo, but we start with this. Okay, so let me get to terminal. As you can see, we have just one node, and I can use kubectl to see the current state of the node networking. Guys in the back, is the font big enough? All right. So I say kubectl get node network state in my namespace, and okay, so I have this object in Kubernetes of kind node network state, and in the current specification there's nothing, because it was just created. It reflects the current state, but user didn't specify any extra configuration yet. And in the status part, we see that there is a list of interfaces. I can look for ETH0, and as you can see, it is there. It has IPv4 address, IPv6, and it's up. So this works. Now, in Kubernetes, for multiple networks, we have something called network attachment definition, which says that if the user asks for to be connected to this network, it will be done in this way. I will show you how it looks. Okay, this is just a simple one. It's network attachment definition. The network is called Blue Network, and it says that if someone asks for it, the pod should be connected to an OVS bridge called bridge 1, and the traffic should be tagged with some VLAN IDs. Now I can create this on Kubernetes. And I can use it for a virtual machine. Now, how does the virtual machine specification look like? It's called test VMI. I was really creative thinking of this name. And then there is some not really interesting from the network, some fields not interesting for networking part, but we have this. We have network section that says we want additional connectivity to the default pod network, but also to our Blue network, which is a Multus network called Blue Network. And then we specify how do we want to attach VM to these networks. And in both cases, we just use a bridge interface to connect to the default network and to the Blue one. Let's create it. And it's there. But it is being scheduled. So let's look in just the side step. When with KubeVirt, the virtual machine is just a process running in a pod. So for each virtual machine, there is a pod created, and virtual machine is started in it. So we can look at the state of this pod. Hopefully. Come on. No. All right. Give me a split of a second to pull up the snapshot of the virtual machine. I'm really sorry. Okay. I just recreated and saved. Okay. So the pod for the virtual machine is pending. And what does it mean? Kubernetes wasn't able to find a node that has requested resources available. So if I look into description of this VM or a pod, it says 0 nodes are available and there is insufficient bridge 1 resource. Because although I defined the node network attachment definition and the virtual machine, we still have just ETH0 and 1. There is no bridge available. And I can prove it to you using Kubernetes enum state. Again, this is the current state of the node, and if I look for bridge 1, it is not there. So we can create it. This is not the current state on Kubernetes. This is my description of node network state. And it has, in the status field, there is nothing, because we don't want to update status, just the spec. And In there, we say the desired state has two interfaces, one of them being OVS bridge called bridge 1, and it has some bridge options, and it is attached to a port ETH2. On those pictures, I use ETH1 to forget about it. And there is configuration for the downlink for ETH2, and we don't want any IP address on it, we just want it to be up. So if I apply this, now, okay, this is a state that is applied on Kubernetes. The spec is in there, and hopefully it will be also reflected in the state. So if I look for bridge 1, it is, this is the spec, this is the status, so you see here. And there is an interface, it's a bridge interface connected to ETH2, yada, yada, yada. It is in there. So now, if we are lucky, the pod should be already being starting on the node. Okay, I guess we are in offline demo, so I ask you to, again, forget about this, and I will get to my backup slides to show how it's supposed to look like. Now, the image that hosts the virtual machine is hosted on Docker Hub or on some remote registry, so we failed to download it on this network. So, yeah, thanks for pointing it out. I'm in the flight mode, so there's, okay. This is the demo, so if you want to rewatch it again at home, you could. Okay, here we applied the node network state. We checked that it was configured, that has been already done. And as you can see, the pod is running right now. And how does it look like? On the node, we already have the bridge 1, and there is just the pod, no virtual machine in it. And the pod has access to the default network on ETH0 interface. Now, thanks to the Multus and network attachment definition, we also got access to the secondary network on ETH1. And then we start our process that happens to be our virtual machine there, and we connect it to these networks. And here I can also show you that the VM is running, and if I connect to it using console and log in with password Fedora and look for IP address, you can see that there is ETH1 and 0, and both of them have IP addresses assigned. So, as I said in the beginning, for some use cases of Kubernetes or virtual machines, the default network is just not enough, and we need access to secondary networks to provide private connections between pods and between containers and VMs, or access to some high throughput networks. And these requirements, if you know about them on day 0 or 1, you can pre-configure it using Ansible and forget about it. But if you need to dynamically reconfigure your nodes, you might be interested in using Kubernetes nmstate that gives you a simple access to configure your nodes and networking just using kubectl and definitions of states instead of accessing those machines and manually configuring, adding and removing interfaces there. So that was it, and thank you for listening. If you have any questions or comments, now it's the time. I didn't upload it yet. I repeat the question. Is the presentation or slides available online? Not yet, but they will be uploaded to the FOSDEM webpage.
Speak louder, please.
Yes, so starting with the Ansible thing you said is that I can say for sure it's not a good idea, especially for the big networks, because it doesn't burn. So I would say that it's not even a consideration, right? So
Please close the door. Guys, we are not done here. Please close the door. We are not done here. Thank you. Sorry.
considering that you have, let's say, you are working on some kind of scale, right? And you say that you can configure your interfaces, and you have cases that you want to shift away traffic. How this can work on applying or stating the configuration in a mass network?
Can you repeat the last part, please?
Yes. So let's say that I have use cases that I need to shift away traffic, right, from a VM to another VM.
Mm-hmm.
Can this how this can be other solutions like agent-based solutions for deployment?
So the question is whether we can use this to redirect traffic from one VM to another, like instead of the destination won't be VM1 but VM2. Well, yes. So this tool is to configure the node networking, not networking between, like from a point from a VM. How do I explain it? So you use this to configure your bridges and stuff like that on a node, but in your case you probably need some overlay or a way to tell the VM on the other side to now don't talk with this one but another one. Well, I don't think that NM state solves this for you or gives you tools to do that. I think that's for another layer of networking. This is for the node part, and you probably need some layer on top of it for the VM part. If it answers your question, yes?
Yes, will it support creating the virtual function on the mix and also DPDK, for instance, if you want?
Well, right now it doesn't, but thank you, Peter. So the question is whether we support configuring DPDK or virtual functions on interfaces on the node. Right now we don't, but we aim on providing the SRIV configuration because we need it in our projects right now, and even the DPDK can be configured there, and patches are welcome. It's the tool is definitely open for it, and there is place to define such attributes. It's just not implemented yet. All right, that's it. Thank you very much.